Now we are going to discuss about the chemical formula of a compound. In simple language, actually a chemical formula is a short way to write the composition of a compound using symbols and numbers. For example, you are having a compound H2O, that is water. This method of writing is known as chemical formula. Now, from this chemical formula, you can understand that which elements are present in this compound. Next thing, you can understand that how many atoms of each element are present. For example, one atom of oxygen element is present in this compound and two atoms of hydrogen elements are present in this. So, a chemical formula is a way of expressing information about the proportion of atom that constitute a particular chemical compound by using single line of element symbols and their numbers. Sometimes other symbols such as dashes, brackets, plus or minus signs are also there. These plus and minus signs are present in the case of ions, which we will discuss later. Plus sign is seen in cation and minus sign is seen in anion. For example, this is ammonium ion. So, in this chemical formula, you can notice this plus sign, subscripts and superscripts. Like this, if H2 is written, 2 is written on the lower side. This thing is known as subscript. But if this is written like this, NH4 positive, this plus sign is written on upper side. This is known as superscript. Now let us discuss some important compounds and their molecular formula. For example, water. Its formula is H2O. Two atoms of hydrogen and one atom of oxygen. Similarly, ammonia, it suggests that it is made up of one atom of nitrogen and three atoms of hydrogen. Next, sulfuric acid. It suggests that it is made up of three types of atom: hydrogen, sulfur and oxygen. Two atoms of hydrogen are there, one sulfur atom and four atoms of oxygen. Now next, sugar. Sugar is a type of carbohydrate. Its molecular formula is C12H22O11. So it contains three types of atom: carbon, hydrogen and oxygen. It contains 12 carbon, 22 hydrogen and 11 oxygen. Then cuprous oxide and cupric oxide. Note the valency of copper here. In this, the valency of copper is 1. In this, valency of copper is 2. And the molecular formula are also different. Cuprous oxide is Cu2O and cupric oxide is CuO. It suggests that in cuprous oxide, there are 2 atoms of copper in combination of one atom of oxygen. But in cupric oxide, there are only one atom of copper and one atom of oxygen. Similarly, in the case of ferrous chloride and ferric chloride, in ferrous chloride, there are in total 3 atoms. One atom of iron and 2 atoms of chlorine. In ferric chloride, one atom of iron but 3 atoms of chlorine. Now comes the difference between atom and molecule. So atom is the smallest particle of an element which cannot be further broken down. and it retains the properties of that element. Atoms normally do not exist independently. However, molecules can exist independently, and molecules are actually the chemical combination of two or more atoms in a definite ratio. Why this is definite ratio? Because of the law of constant proportion. There is a ball here. This blue ball. This represents an atom and it cannot be broken down further. Suppose there is a combination between this blue ball and this pink ball. Right? Now this is known as combination of two atoms, means a molecule. Now we come on valency. So valency is actually the combining capacity of any element. We know that atoms combine to form molecules, but a single atom can combine, or you can say can form a bond with how many other atoms. So that how many is known as valency. So the combining capacity of an element or its atom is known as valency. It is expressed in the terms of number of hydrogen atoms or chlorine atoms, or double the number of oxygen atoms that combine with one atom of that element. For example, CH4. There are 4 bonded hydrogens here. Therefore, the valency of carbon is 4. In case of CO2, we know that we have to double the number of oxygen. So, carbon is bonded with 2 oxygen and now we have to double the number of oxygen, that is 2 into 2. So, again the valency of carbon is 4. Now, see some examples. In ammonia, NH3, nitrogen is bonded with 3 hydrogens. This is the structure. So, the valency of nitrogen is 3. In H2O, the valency of oxygen is 2 because it is bonded with 2 hydrogens. In case of methane, we have discussed that the valency of carbon is 4. In carbon dioxide, we have discussed that the valency of carbon is again 4. In sulfur hexafluoride, SF6, you can say that one sulfur is bonded with 6 fluorine atoms. Therefore, the valency of sulfur is 6. Many elements exhibit more than one valency. For example, phosphorus. In PCl3, the phosphorus is forming a bond with 3 chlorine. Therefore, the valency is 3. In PCl5, phosphorus is forming the bond with 5 chlorine. Therefore, the valency is 5 here. Common valency of some non-metal elements. Have you seen the compounds like hydrochloric acid, HCl, hydrobromic acid, HBr, HI, HF? In all these compounds, you can see that hydrogen is bonded with one chlorine, hydrogen is bonded with one bromine, hydrogen is bonded with one iodine, and again hydrogen is bonded with one fluorine. So in all the cases, the common valency of hydrogen is 1, and in fluorine, chlorine, bromine and iodine, they all are two bonded with only one hydrogen. Therefore, the valency of chlorine, bromine, iodine and fluorine is 1. Now we come on carbon. We have discussed that the valency of carbon is 4 as we have seen in molecules CH4 and CO2. The valency of nitrogen is 3 as we have just seen in the case of NH3. You can see it in NF3 also. In oxygen, the common valency is 2 as we have just now seen in the molecule H2O. Sulfur and phosphorus, they both show variable valency. Sulfur can show the valency 4 and as well as 6. Similarly, phosphorus can show 3 as well as 5. The case of phosphorus we have discussed before in PCl3 and PCl5. Similarly, in sulfur, Notice SO2 and SO3. In the molecule SO2, to find the valency, you have to double the number of oxygen atoms. There are 2 oxygen, therefore 2 into 2 will be 4. In this case, the valency of sulfur will be 4. In the case of sulfur trioxide, that is SO3, again you have to double the number of oxygen atoms, that is 2 into 3, the valency will be 6. In this case, the valency is 6.